Hi, welcome to IP version 6 series of my record videos. Today I am going to discuss advanced IPv6 topic. I am Kundan from technical team of Network Firewall. Here we are going to discuss operating of DNS with IP version 6. In IP version 4, we have the A record. In IP version 6, that we have the quad A record. There we have the IP version 4, we have the www dot suppose abc.test A and A record host name to IP resolution 192.168.30.1. Here we have the same, then quad A and then IPv6 address. So host name to IP address resolution, we have the A record. In IP version 6, we have the quad A record. IP address to host name, pointer record. Here we have the pointer record, only format has been changed. What we have in IP version 4, that is completely different what we have in IP version 6. IP address to host name, pointer record, origin, addresses we have, ARPA A, IPv6 ARPA A, then CIDR 64, and then 1400 in pointer www.abc.test. And Cisco iOS IPv6 DNS client support. Cisco iOS has been IPv6 DNS client support. Queries DNS server for IPv6 to IPv4. First queries for an IPv6 address, quad A record. If no IPv6 addresses exist, queries for an IPv4 address, A record. When both IPv6 and IPv4 records exist, IPv6 address is picked first. Static host name to IPv6 addresses can also be configured. Like example of DNS queries, DNS server router A, first DNS resolver verifies the IPv6 quad A record first. Then query generated www.example.org type quad A. DNS resolvers verify for IPv6 quad A record first. Then we have the response. After query, we have the response, that is IPv4, IPv6 address along with the quad A. So DNS resolver first verifies the IPv6 quad A record first, and then after response, again non-exist query has been generated, and then we have the response. This way, DNS in IP version 6 work. So DNS commands for IP version 6 configuration define a static name for IPv6 addresses like IPv6 host name, port, IPv6 address, IPv6 example IPv6 host router 1. We have given the host name router 1. Then 3FFE colon B00 colon FFFF colon V double colon 1. And configuring DNS server to query IP name server addresses. Example IP name server, and what the server address we want to assign. And IPv6 and dynamic DNS. Dynamic DNS provides the capability for secure, authenticated updates of DNS zone files. Updating agent is typically dynamic DNS aware DHCP server. Provision of globally routable client system IPv6 will lead to greater emphasis on reachability by name for nodes with routable but not static address. Dynamic DNS constant. Dynamic DNS is not yet widely deployed. Now we are going to discuss advanced IPv6 topic for DHCP. In DHCP in IP version 6, we have two functions, stateless and stateful. Stateless DHCP is specified by a combination of stateless auto configuration, stateless flag, and DHCP for IP version 6. When router sends and route advertisement with O bit set but does not set the N bit, the client can use flag to obtain its IPv6 address and use DHCP v6 to obtain additional information such as TFTP server address or DNS server address. Stateful DHCP, when the M bit is set the setting of O bit is irrelevant because the DHCP server also returns other configuration information together with the address. So this mechanism is known as a stateful DHCP v6 because the DHCP v6 server tracks the client address and binding. In stateless, DHCP server doesn't track the client address and binding. In stateful, it does. Any IP version 6 DHCP messages we have solicit message, then advertise, then request, and then reply. So DHCP v6 an updated version for DHCP for IP version 4 supports new addressing, allows more control than stateless auto configuration, can be used for renumbering, can be used for automatic domain name registration of host using dynamic DNS. Its operation is same as in IP version 4 with these exceptions. Client first detects the presence of routers on the link. If found, then examine router advertisement to determine if DHCP can be used. If no router found or if DHCP can be used, sends DHCP solicit message to all DHCP agents multicast addresses, uses the link local addresses as the source address. And DHCP also works with the help of DHCP with multicast addresses. So multicast addresses used FF02:1:2 all DHCP agents, server or relays, link local scope. FF05:1:3 all DHCP servers, site local scope. So Internet System Consortium we have bind HTTP. These are the addresses which works for DNS and DHCP. DNS extends support IP version 4, IP version 6, RFC 3596. Internet System Consortium, DHCP, HTTP, www.isc.org. Dynamic Host Configuration Protocol for IP version 6, DHCP v6, RFC 3315. Security Architecture for Internet Protocol, RFC 2401. IP Authentication Header, RFC 2402. IP Encapsulating Security Payload, ESP, RFC 2406. IP Mobility Support for IPv4, RFC 33344. And Mobility Support in IP version 6, Draft ITF Mobile IP IPv6 20. Thank you.